All right, the last topic that we're going to talk about in this section is expected value. And in a lot of ways, we've already done this. Okay, we've been doing this a lot. This is just a different term for something that we already know about. So, expected value is the value you expect to get if trials were repeated an infinite number of times. Okay, the value you would expect to get if trials were repeated an infinite number of times. Okay, so one special thing to note, expected value is the mean. Okay, because what do you expect to happen over the long run? You expect things to happen the average number of times, right? Over the long run, you expect things to come out to the average, exactly what it should be in the middle. And that's what expected value is. It's just another term for the same thing we've already talked about. Okay, so let me give you a couple of examples. Expected value usually shows up in slightly different looking scenarios, such as this one. Okay, that's where these terms come from. It's just from different contexts more so than anything. So in a pick three lottery, a player pays $1 and picks a 3-digit number. If those numbers are picked in that specific order, the person wins $500. Okay, what is the expected value of this game? So if you play this game over the long haul, what do you expect to happen? Okay, on average in the long run. So what are the two basic things that could happen? Well, you could win or you could lose. Okay, those are the two things that could happen. I'm going to do lose first. Okay, if you lose, what happens monetarily speaking? You lose $1. Okay, so you are out $1, a negative dollar. Okay, if you win $500, but remember, it did cost you $1 out of your pocket to play the game, and so you are now ahead by $499. Okay, basically that first buck was yours to begin with, but you win an additional $499. Now, what is the probability you would win this game? Okay, what's the probability you win this game? Well, if it's a pick three lottery and there's a 3-digit number, the probability you would get those numbers right in order would be 1 out of 10 for the first digit, times 1 out of 10 for the second digit, times 1 out of 10 for the third digit, or 1 out of 1,000, 0.001 in decimal form. That's the probability you win. Okay, what's the probability you lose? Well, you would lose 1 minus 0.001 or 0.999, 99.9% of the time you would lose. Okay, so what we're going to do from there is then we're going to multiply the x value in this column times the probability value in this column. So 499 times 0.001, so 499 times 0.001 is 0.499. Okay, similarly, when you take negative 1 times 0.999, you end up with negative 0.999. That was a tough one, right? Okay, then for expected value, you want the sum of the x times p of x's. In other words, you want to add that last group of numbers together. You want to add the x times p of x's together. So when we add those together, we come up with a result of negative 0.50. Okay, now remember, this is in terms of dollars. Okay, so what does this mean? So when we're talking about expected value, we're talking about trials repeated an infinite number of times. This is a long run prospect. Okay, so what this means is in the long run, you will lose an average of 50 cents per ticket on the pick 3 lottery. Okay. Now, I know you're saying, but you don't lose 50 cents. You lose $1 or you win. Yes, I understand. But again, this is in the long run. You might pay $1 and lose for 20 weeks in a row. You're out $20, okay? But in the long run, if you keep playing, okay, the expectation is eventually 1 out of 1,000 times you'll win. And in the end, you'll still end up losing money, about 50 cents per play. Okay, is this a fair game? No, this is not a fair game, and here's why. Okay, if it was a fair game, we would expect to break even in the long run. Okay, in other words, we want the expected value to be 0. That's what breaking even in the long run would mean. Okay, you would neither win nor lose money. Okay, if it's a fair game, you come out even. Hopefully that makes a little bit of sense. Okay, let's look at one more scenario where expected value comes into play. Okay, so life insurance or any insurance company, they'll talk about expected value a lot. This is part of their bottom line. So an insurance company sells a $250,000 1-year policy to a 20-year-old guy for $350. If you want some nighttime reading, check out the National Vital Statistics Report. It'll put you to sleep right away, I promise. The probability that the male, that 20-year-old male survives the year is 0.998611. So all you 20-year-old guys out there, it's looking pretty good that you'll hit birthday number 21. That's the good news. Compute and interpret the expected value of this policy to the insurance company. Okay, so what are the things that could happen? Okay, well, this 20-year-old guy could live, or unfortunately, this 20-year-old guy could be in the category of he dies. Okay, if he lives, now notice here we have words expected value to the insurance company. This is not about the dude. This is about the money, the company. Okay, if the guy lives, what happens? Well, he paid his $350, right, for his insurance policy, and the insurance company keeps it. That's what an insurance policy is for. Ooh, pen again, not the highlighter. Okay, so the insurance company gains $350. Okay, what's the probability? I'm going to work across. What's the probability they get to keep their money? Because the guy lives. Pretty dang good, right? 0.998611. Really high probability they just get to keep the $350. However, maybe he's an unlucky guy, okay? Maybe he's in an accident. Maybe he ends up with cancer. In today's age, maybe it's COVID. We just don't know. But for whatever reason, he doesn't make it, okay? What does the insurance company have to do? They have to pay $250,000 to the survivor, okay, of this guy, or survivors, whoever that is. So they collected $350, but then they have to pay out $250,000. So that is an overall loss of $249,650. Okay, how often does that happen? Well, not very often. 1 minus 0.998611 happens to be 0.001389. Okay, doesn't happen very often, but again, it could happen. So now we're going to come along and we're going to multiply the X value times the probability. So what the insurance company gains in this case times the likelihood they get to keep the money. We'll round to the nearest cent because we are talking about money. So that's $349.51. Or they could lose $249,650. Again, a pretty slim chance, but it can happen. That would be a loss of $346.76. And then the goal is to add those together to come up with the expected value. which ends up being $2.75. So what does this mean? Okay, so on average, the insurance company, I'm going to do some abbreviating here, okay, the insurance company makes about $2.75 per policy for 20-year-old males. Okay, so every time they write a policy like this, on average, they're making $2.75 because eventually, yes, some guy's going to die, unfortunately, and they are going to have to pay it out. But again, we saw the vast majority of the time, they're just going to keep that $350, and that's the money that gets used to pay out for whenever other people do have insurance claims. All right, so that's expected value. That is the end of section 5.1. So go tackle the homework, and as you have questions, be sure to ask.